Thank you for joining. Let's just get started. My name is Abdi. I'm from MonsoonSIM, and here with us is Derick from Melbourne. Okay. Yes.
Yes. Okay.
Yes.
All right. So data analytics, definitely something that's continues to up the list of in-demand skills for the 21st century. And as Christine was mentioning before, it is becoming more important for business students to take on this role of advisors and decision makers and not just counting the beans, right? And so data analytics definitely plays a role in that. As technology becomes cheaper and storing vast volumes of data becomes easier and almost negligible cost, access to this data to support decision making and being able to take advantage of that information is definitely something that prospective employers are increasingly looking for in graduates. Just a little bit about me. So I've been a long-time gamer, probably played my first computer game when I was about 9 years old. Been working in the gaming and simulation space. Some of you perhaps may know me from my days over at the HEC guys in Montreal with the SAP simulation. So worked a lot on that, and I've been a long-time collaborator with Abdi. And more recently, sort of the last 5 years, I've really turned my attention to this whole data and analytics piece. So just to frame really what's all that is about, I really like this quote from Puget here. And the emphasis really is, it's not about just creating some graphs or running some numbers on the data, right? Which is sort of, again, that accounting perspective like that Christine was mentioning. We've got to do a lot more these days than just add up the numbers, right? It's all about making decisions, and it's all about supporting decision making. And what do we mean by support, right? And so there's another perspective here that Gartner has, which is the level of sophistication of your analytics effort. And it's a large part here of what's in blue is what we're getting technology to do, what we're getting the software to do, and what's over here in green is what we still want human minds to accomplish, right? That make this end decision. And sometimes people and students have a focus that they forget about, using their own brains, their own critical thinking in this piece, and just expect somehow that they'll be able to use this technology to tell them what to do. And it's not really about that. It is about developing perspective on what's happening, interpreting that, and then informing that to say, well, perhaps we should try X, do that experiment, and then see how it goes, right? And this is sort of really the cycle that we want, that they learn to think for themselves, learn to investigate, learn to experiment, and then learn to measure the outcomes of those experiments in this decision-making context. And so the purpose of the analysis is very important. It's very easy to give somebody some data and some tools and say, go off and create some charts, and they'll go and do it, but then those charts aren't necessarily meaningful, and they aren't there to aid decision-making, because unless you understand exactly what the decisions are that we're looking to support, you're not going to be able to create anything particularly helpful or anything particularly meaningful, right? And so ideally, if you want to add analytics to your curriculum, and again, it depends on how much space you want to give it and what your learning outcomes might be and how deep you want the students to go down the rabbit hole, or whether you just want to give them a brief interaction with a tool like Tableau or Power BI, or even Excel and Power Pivot in Excel to do a little bit of data crunching just to see what it's about. So from a light outcome to a deep outcome. But what I'm going to be really spending more time on here is if you want those outcomes to be a bit more deeper, getting students really to think critically, think for themselves, then this is how we can support them. So ideally, we'd want the students to sort of experience all of these, right? And if we go back to the Gartner one, a lot of the time the basic stuff is just, well, what happened, right? So I create a line chart and I see the line went down, and so I interpret that as that's a poor outcome, and well, end of story, right? And so, well, could we have done, why did it happen? Why did it go down? What were the factors that were influencing our revenue to go down, for example, right? Did it go down consistently, or was there a period of significant, downward trends in the revenues that we were accumulating through the year or whatever, right? So, well, why did that happen? And could we have seen it? Could we have foreseen it, right? Was there some sort of indicator as a month or two before that would have given us a clue that that was about to happen to us, so that we could have taken some sort of intervention um, to prepare for that, limit the effects of that, or even possibly avoid it, or turn that situation around, or to our competitive advantage. And so that's really what this purpose of the analytics is all about: looking for these trends, looking for patterns, setting ourselves up to be in the best position to prevent unfavorable outcomes and promote favorable outcomes based on our predictions and the trends and patterns that we're observing, all action through the decisions that we take. And so, this question of purpose really comes around the framing of questions. And this is something that students are typically weak at, in terms of how do you frame a good question, right? So I put this example up here. This is one of the slides that I use in my data analytics class. What is the best car, right? And it sounds like an innocent enough question, but best is very vague, and in what context, right? So if it's which car is going to do the fastest lap around Albert Park here in Melbourne, driven by a professional racing driver, well, we can pick which car that's going to be, right? But if the context is which one gets my 80-year-old grandmother safely to the supermarket and back once a week just to get her groceries, it's not going to be the Formula One car, right? What about if there's budget constraints, right? So this whole context of what do we mean by best in what situation, based on who's performing the task, what is the outcome, what's the objective. And so depending on that framing, each one of these could be the correct answer, right? On what is the best car, not necessarily what is just the fastest on a racetrack, for example. So I like to present sort of this three-legged stool here, because everybody thinks about, yeah, we need fancy software, and obviously we need data, and then we can go off and do our analysis, right? But the three-legged stool, the metaphor here is, without one of those three legs, basically you've got nothing to sit on, right? It's not stable. And so we can't forget this purpose leg over here, and a well-developed understanding of what is it that we're trying to do, what are the decisions that we're trying to support. So a little bit about visualization. This is really trying to take some abstract information and display that in some way that leads us to develop a deeper perception of those things we were looking for before, right? Understand what's happening in the world around us, predicting events, looking for trends and patterns, doing forecastings, and things like this, right? And so it's really this question of taking some data, visually encoding, which really means create some sort of charts and things like that. But charts have to be interpreted, and so there's also this human perception involved in understanding what you're looking at. And again, context matters. Line chart, line going up, line going down, good or bad? Well, it depends. If it's cost or if it's revenue, we can interpret that differently, right? And so the perception has to be also anchored in a context about the phenomenon, right? So where is the data? What is it measuring? What are we looking at, so that we can also interpret this line chart, whether that means it's a good thing or a bad thing, right? And so once again, here Stephen Few, who was a pioneer in modern visualization, software visualization techniques, really again coming down this understanding for action. Is that same principle of supporting decision making that we've been discussing. So not all charts are created equal, which is why if you read my bio, I've got this little joke there about being on a mission to kill the pie chart. Because this is one of my slides from my class, and as you can see, basically the way that our eyes and our brain processes visual information, not everything is created equal. There's different levels of accuracy, right? And so we can detect subtle differences in the position of things and the lengths of things, but when we get down to slopes and angles and areas and volumes and shades and things like that, the accuracy of our perception falls off. Now, students find this all very theoretical, and sort of, yeah, blah, blah. And so what I do is I give them 2 quizzes. Before I teach them anything about visualization, I give them 2 quizzes. Same data, very similar questions. The only thing is I change the type of charts. And when I show them these results, they're quite astonished at just how badly they do with typical pie charts for things. And when you've got more appropriate things like even simple bar charts that they take for granted as boring, just how much more effective, and you see even the average time to take the quiz goes down, right? So the entire class gets a much better result in 2 minutes less, right? And so then they start to pick up the interest, like, oh, okay, there's something here. This is worth learning about in effective visualization techniques, choosing the right chart for the right job. Which brings me to, whoops, sorry, I got my slides slightly out of order here. This gentleman here, I learned a great deal from his blog about visualization. He has this thing called the junk charts, and he really proposes that there's this three elements here, and the interaction of these 3 elements is extremely important. And he's once again placing the emphasis on understanding the purpose of what it is that you're trying to do, what is the question that you're trying to inform, what are the decisions that you're trying to improve your performance when making those decisions or optimize those decisions. And so there's this interaction between, do you really understand the question? Do you really understand what your objective is? Do you have the right data to inform that question? You can always go and look at data that's not relevant, right? Or data that's slightly distorted or missing a certain perspective, right? We can look at different data, different perspectives to try and get multiple perspectives on the same question to deepen our understanding. And then, what does the chart say? Which is basically how have we chosen to visualize the data? And so there's a lot of focus that tends to be just on the bottom 2 here, right? Oh, we've got some data, let's create some charts, and hopefully it's going to give us some insight or tell us something. That's really the wrong way to think about it. It really should be, what is the question? What is the data I need to answer the question? And then what is the best way to visualize some data to be able to give me the easiest, quickest, most reliable perspective on that gives me insight into that question. A little bit about software-aided visualization. So tools like Tableau and Power BI and others have come a long way. In the past, there was a lot of, well, I got some data, and then that would be put into a report, and that report would then be presented as a PowerPoint, static, or sent out as a paper, printed, or a PDF, right? And there's no interaction with this, right? And so if we want to deepen our understanding of what's happening in the world and the data, we need to interact. We need to interact with the data to gain different perspectives and also interact with the visualizations. Now I'll show you what that means when I come to do the live demo and what we really mean by interacting with the visualization to deepen our understanding, but really explore the data in different ways, looking at it from different perspectives to truly understand what is being measured in the context that we are looking to influence. And so this reinforces a few very old sort of learning models, and these came out of not education in a formal sense, but more institutional learning. They are fairly well known with Kolb and Aguirre, basically the double loop learning and Kolb's learning cycle, which is, how do people go out there and sort of learn in the wild? And when we bring that into the classroom and let's sort of think about how these sort of might work in a typical classroom experience, where let's say you want to teach data analytics and you're going to do that with some sort of a case study, right? So there's a case, it has some background story to give the students their context. You give them some data associated with that, and then they're asked to perform an analysis and make a recommendation, right? And if you think about that, there's no real concrete experience in this concept. There's possibly not a lot of observation and reflection, and mostly we start off with whatever the subject is that's being taught. The teacher is going to influence and impart their wisdom and basically a lot of the concepts, which the students are then asked to apply in a new situation, i.e. the case study, apply what they've learned to the case study, to then produce an analysis and a recommendation, which doesn't feed back into concrete experience or any kind of observation and reflection. It goes straight to basically some feedback from the teacher, and that's it. And so there's a quite a high reliance here on the formation of understanding of the world and what's happening, relies on the teacher imparting that knowledge. And then whether the student has learned those concepts or not relies also on the teacher providing feedback. And so as soon as the student is removed from the classroom and put in the real world, they have to make quite a large leap to then be able to do that themselves without being guided by the mentor of the teacher. So if we look at the Agoras model on the right, so this idea that I was talking about before, that we want students to formulate their own hypothesis, formulate their own mental models about the world rather than be just given that by the teacher, experiment with decisions and then be able to reflect for themselves, not with a teacher's expert guidance, but to reflect themselves whether they made a good decision or a bad decision, right? And so this is where something like a simulation becomes a lot more interesting, because the nature of the simulation is you are repeatedly making decisions over and over again, and then you're given the tools, or you're given, at least in the simulation, for example, the teacher gets to decide on the scoring metric, and so at least you get this from the score, but then you have to deepen your understanding of how your decisions affected a variety of factors that led to you getting, in essence, that score in the game. Let's say it's, the maximum net profit, etc. So this offers the potential, and again, the same. It's not real world concrete experience, but you're getting the experience, that's simulated experience, right? And we talk about this in the gamification, what we call the suspension of disbelief, right? But the students forget that they're playing something that's fake. For them, it's real, right? They really start to believe that they're in it and it's really their business and they care about that business. And as Christine was mentioning, some of them can get quite competitive, as in they want to be the best, right? And so they're highly engaged and they're highly driven. But there's one aspect of simulations that we have to think about is there's a lot of reflection going over here. And for this to really work, the students really need time to think. They need time to reflect. They need time to observe, perceive. And when you're running something in a simulation that has accelerated time, they often feel extremely under pressure to make decisions extremely fast. And so you shortcut the reflection. So they're not often given enough time to really reflect. And so what happens is the decision-making becomes quite tactical. And when you substitute a simulation instead, when we did this in the early days, we thought, oh yeah, we give them the tool, we give them the data from the game, and we don't need to really spend too much time on the purpose. The game is the purpose, right? Win the game or perform well in the game, that's your purpose, and the students will figure out for themselves. They can't. The amount of reflection and critical, the skills development that's happening all through here while they're learning the game, they're learning the business, they're learning how to figure out, detect feedback for themselves, find problems. It's a lot, and it's a lot to expect them to do just on their own without help. So if you really want to go deep and really get them to understand what is decision making, how these tools can support decision making, you've got to do more than just give them some software, give them the data, and then let them figure out the right questions, right? It doesn't really work. Because what happens is, this is the outcome that you usually sort of get, right? Students get so focused on, I've got seconds to make a decision, they become extremely tactically focused, and basically the game turns into this sort of whack-a-mole type thing, right? Where basically they're just looking for problems, and as soon as the problem rears its head, they whack it, right? And if you think about the scoring for whack-a-mole, that's exactly how you score. You hit a mole on the head, you score 1 point. And so the students are highly engaged, they're having fun. It's fun, it's chaotic, and I think they're doing a good job, because basically every time you whack a problem on the head, you score a point. So they think they're doing well. But that doesn't really translate into the real world or even the simulation, because basically avoiding problems actually scores you more points. The moles that you don't whack actually cost you negative points, right? And so we've got to get them out of this mode of whacking problems on the head and start thinking about, how can I prevent these problems in the first place? How can I predict where the mole is going to pop up, right? So that I'm ready and there with a plan to deal with it. And so you got to start thinking about, well, the ones that you miss actually score you negative points. And basically, the longer the mole is up there, the more negative points you score, right? And so you've got to get them to re-engage and rethink out of this tactical mode. So 3 things that basically students need for success. In my many years of running simulations and trying to put analytic curriculums on top of that, is you've got to give the students time to reflect. And we've tried that in a few different ways. Slow the game down, run the game more slowly. But the problem with that is, if the game runs 2-3 minutes a day or something like that, it's still not enough time to really reflect. And then you've got this long cycle of students waiting for something to happen after they've made their decision, and it feels too slow and they disengage and they get bored. So your incentive then, and also you want to generate data and have the game going and move forward. So slower you run the game, the more students disengage. The faster you run the game, the more it goes back to whack-a-mole. And so my recommendation for the solution to this is, let them play the game, short bursts, fast, learn something, but then go and reflect, right? Go analyze the data, go look at your decisions, go determine whether you have made good decisions or poor decisions. You're out of the game context. Here you're investing in understanding what you did before to learn how to basically play the game again a second time and do better, right? Coaching, you need lots of coaching. Now, not so much about how to use the software, or even how to create, good visualizations. What students mostly need coaching around is the formulation of the right questions, right? So I'll walk around class and I'll see somebody has, a typical market share pie chart up on the screen, looking at it and going, okay, so that's interesting. So what's it telling you? Well, what do you mean? Well, of the business decisions that you've got to make in running this company, what is it telling you what to do? Well, what do you mean? Well, what are your decisions? Well, I don't know, pricing. Okay, so did you change your price recently? Oh, yeah, we actually dropped it a few days ago. Okay, so what does this pie chart tell you about whether that was the right decision? Did you have dropped your price or not? How much did you drop it by? Was it too much? Was it too little? And they look at it and they go, I don't know. And this is where you have to intervene, and you've got to tell them that it's not the tool's fault. It's not, oh, I don't get this. This is dumb. This doesn't have any value. Let me just go back to whack-a-mole. Is you've got to coach them that they're not asking the right questions. They're not thinking about the questions that they want answered, which is, well, what visualization and data do you need to answer the question of, the price change I made 5 days ago, did it have the effect that I wanted? Did it promote the outcome that I was looking for? What was my goal in dropping the price? I wanted to increase my sales and the revenue. Well, did that happen or not, right? And so you've got to coach them in this reflective exercise of how they formulate the questions, to then get them to thinking about, okay, the visualization that I would need and the data that I would need to answer that question is this, rather than just, I got some data, I created a chart, and then I don't know what to do with it. That doesn't mean anything to me, right? And the other thing is, it takes a lot of time and a lot of skill, in my experience, a lot of practice. And so you've got to give them lots and lots of examples. And so one of the key things that I would do is, best way to get them engaged in the example is, when you are at some pause point or some reflection point where you're going to discuss their performance, is to actually use the analytics tool and to create things for yourself ahead of time that you use in the debrief, right? And so here's an example of a dashboard created with Tableau that's sitting on top of live real data from the game, plugs in. And so, at some point you refresh this, takes a few seconds, and here you can then start to debrief with the students. Well, okay, so which team is doing the best? Well, this blue team over here has the highest revenue, and that you can see from the line that their performance has been consistently, right? They've been consistently outperforming the other teams, right? Now, this is robots playing the game, so the robots are actually pretty good. And so there's less chance here, but for most player-generated stuff, you would often see that these lines stall, and you're like, "Wow, what was happening over here?" You're like, how do we interpret this flat line? Well, that means we didn't get any revenue for 10 days. Okay, so what was happening during that 10-day period that would have caused that, right? And so you start to bring into them in your debrief, discussing and showing the performance. So informing them on the kind of things to look for and the way that they can use the visualization tool to look at that. Now, you got to do this in a way that you're giving them perspective that they don't already have. So recreating things that are already available in the simulation reports itself is not really worth it, because they're like, well, we've already got that, right? So and a lot of the things that the students don't focus on and they don't necessarily have or see in the simulation is performance over time, how situations change over time. And so in sort of a debrief like this, I'll always try and have a lot of charts in here that show things over time, to draw back to go and reflect. This is interesting. What was happening in this period? What happened here that caused this spike? There's another spike over here, right? It seems that all the teams were affected. What was happening in the market? So here we see total market revenues. So it seems that demand is not even. So what does that mean for inventory planning if our sales are not steady and we've got some days where sales spike? How do we prepare for that? Maybe we should carry some extra inventory. Can we forecast or predict? Is there a pattern to how often these spikes happen, right? And so you start to engage with this conversation, get them thinking on what to do. So I'll just flip over here to the live version of that. So just to show you, and this is what I mean by interactions. I actually changed this one up a bit to show the revenue of the different teams here. But when we're talking about this idea of interacting with the data, interacting with the visualization, just say, okay, this is all very interesting, but what if I want to look at all like Melbourne here seems to have pretty good sales, right? And so got this little heat map here that basically shows where the bigger markets are, right? So okay, there seems to be a lot more revenue being earned in Melbourne, and so this is the power of tools like Tableau, where now you can click on something and you get this interaction where I've selected Melbourne and it's now filtered all the other charts, right? So now I'm looking at basically the inventory of each of the teams over time, specifically in Melbourne for the various 3 products, looking at revenues just for Melbourne, and basically the teams earn revenue fairly evenly in this big market. Let's go have a look at, say, something like Sydney. And so here we discover, oh, now look, there's only 2 teams, right? So only 2 teams are operating in this location. So maybe there's an opportunity there. There's not that much competition, so teams might think, oh, maybe that's a good spot to go and open another location versus somewhere else, like Brisbane, where I don't know, everybody's already there. And so they start to formulate, oh, what should we do? What sort of the strategy should be? And then what's really fun is they'll make their decision and think, we've got it, but they don't realize that every other team has discovered the same thing. And so they rush in and they get the outcome, they look at the outcome and they go, oh, that didn't work. And you ask them why. And so this is the aspect of replicating what's happening in the real world. And the quote that Abdi put up from the American professor before, there's a line there that he didn't have, but decisions don't just operate in this vacuum, right? At a point in time, you make the decision. Other people are also looking at things and they're making the decisions at the same time. And so you could find that all the teams discover, oh, there's an opportunity here. So they all go and open locations there because they all see the same opportunity. And so the decision that you think was awesome and was going to do you great, well, everybody also saw the same opportunity and did that too, right? And so this is this other reflection of, yeah, okay, it's not just me. I've got to find something and I've got to get myself in a situation where it's not just finding the secret recipe or the secret ingredient. It's I've got to do everything better everywhere all the time than all the other teams to truly be competitive. So quite fond of the heat map thing in terms of selecting a particular product, filtering the other charts, or even down to a single cell. It's a really nice, compact, summary way of showing how revenues are broken up in the market. A lot more density of data than a pie chart and much more easier to interpret, and then also gives us this really nice way of interacting and drilling down into the segments to see, oh, well, there's only 2 teams serving this particular product in this particular market. How's it going? Who's doing better? Generally, you'll see, especially in the early stages, as people still learning the game, that you'll see flat lines over here with basically people running out of stock all the time. And so you reinforce their focus away from things like, oh, it's all about pricing, and start thinking about, well, having a sale with no product to sell isn't going to get you anywhere, right? So you've got to think about your supply chain. You got to think about inventory planning, the things that don't necessarily come naturally to them because they're not, those things are not always fun, and they don't immediately think of them. Oh, how do I increase sales? Decrease my price, right? That's this mental model that they have. Well, how do you increase sales? Actually, don't change your price. Buy more stock and buy it sooner, right? And so this is the kind of reflection and the sort of critical thinking and the loops and the understanding of the game that we want them to develop. And so I'll just put up one last slide, which is this one over here, which is basically we want them to really doing, whoops, sorry. It's all of this simultaneously, right? So as they're learning to understand the phenomenon of the game better, as they're learning to understand their mental model of how that works, their ability to influence outcomes, how the outcomes are being measured in the data that's being collected, how they choose to show those to inform them on whether their decisions are good or not, at the same time learning about creating better visualizations, learning about being more selective about choosing the right data to give them the impression of whether the decisions that they're making are any good, and the framing of the question, right? And so all of these things, all these sort of feedback loops is exactly the potential that we have when we integrate a simulation context that's highly engaging with a visualization tool like Tableau. But there's a lot of cognitive load on the students to do all of that, and so they need a lot of support to do that. You've got to coach them. You've got to give them breaks. You've got to tickle their thinking if you really want it to be successful, because otherwise it's too hard and too time consuming, and they don't see the benefit, and then they really don't really understand, and they miss the potential of the tool. So I'm mindful that we're already at 8 minutes over time.
Excellent. Thank you, Derick. This is Abdi, back to me again. It's really good. I don't know if any of you, I assume some of you have used MonsoonSIM data to study data analytics. I don't know if any of you have anything to add or have anything to share or have any questions.
Yes, Mr. Abby. Hello?
Yes, yes.
Sure again. So may I ask, for the coming competition, will the teams be allowed to access the database?
Yes, of course. Yes, we will make it available. So feel free to, yes. It's in November, right.
But for national, will the means like the database, like just now the live data access? Of course, each team will be given their own database to be accessed. Is it going to be
when you have your preliminary round, you guys can go ahead and practice that. But when we have a competition, then we'll open up the data, the credentials, so they can they can use it. But given the time is short, and as Derick says, they really need time to reflect. I don't know if we have if they can really help them make any decision, but nonetheless, it's a very good it's a good exposure. It's good experience for the student to tap into the data. I mean, last competition in Hong Kong, a number of Hong Kong PolyU students actually use Tableau to look into the data. But last year they were using live, the exported data. But this year you can use live access. So, yes.
So that means live access will be allowed.
Yes.
Okay, that's all I need to ask. Thank you.
Just a nuance I didn't mention before, but what I was showing in the dashboard, as the example of the kind of thing I would use to debrief the game outcome with the students. That's using the instructor login, which has access to all the data from all the teams so that you can actually compare, right? There's separate logins for the teams where they would only see their own data.
Okay. Any other questions? If not, let me go back to my slide, and I'm just going to close it. There's some contact here for you guys. Are you looking at? Okay, so here are the contact. If you have some question that you like to ask, we have in Australia, New Zealand, you can contact me directly at MonsoonSIM. In Singapore, Malaysia, you can contact Alex at MonsoonSIM.com, and in Philippines, please contact Donald. All right, and they are here. Donald at MonsoonSIM.com. All right, very good. Thank you so much, Derick. Thank you for the insights. Amazing stuff.
You're welcome. Thank you for having me.
A data analytic expert. Really, you really walk the talk and so on. So it's really good. Okay, for the rest of you, we thank you so much from MonsoonSIM, really, and we hope to see you in the trainer session 27, 28. All right. So thank you all one more time.
Thanks, Ed. Bye all.
Bye now.